everyone. This is Scott King, and that is Chris Kraus. Hi, Chris.
How's it going?
It's going well. Thanks for listening to this episode of the Union Podcast. Today, we're going to talk about how to choose an LLM, so how to choose a large language model. So there's lots of interest around this area. People are trying to figure out, if it can work for them. If they think it can, now they need to choose, which model is going to be right for them. It's not an easy task, Chris. What are some of the people asking us about in terms of either one, will it work? And then, yes, I think it'll work. How do I figure out which one's going to be best for my business?
Yeah. So we're actually seeing two types of buyers. One is we know LLMs will solve our problem. We need to figure out how to bring it into the organization. We need to test multiple of them. And we're worried because, customer service, knowledge management, self-service if in HR, that's a different use case than like proprietary stuff on the back ends. But the other is people saying like, I've heard of this, but how do I test it to see if it'll actually solve my problem? Like, can it answer my customers' emails in a call center? Or can it answer questions about my product and manuals and that? So we're definitely seeing two camps. One is, we know this will work. We got to figure out which one. The other is, okay, we're early in the life cycle. Will this actually work for my data? Is my business so different that it won't work for me?
And then there are lots of variables, right? Any kind of IT project has resource constraints, have budgetary constraints. I've played with some of the LLMs. I actually subscribe to a couple of them that I use, but I'm just using it for point stuff, right?
Yeah.
In the earlier McKinsey reports that we've covered, sales and marketing is like the number one use case because you can use it standalone, but that's not what we're talking about, right? We want to use it to help a certain business function like HR, like knowledge management portals and customer service, right?
Right. Lots of things with lots of consumers and lots of data. And so that does change the concept, right? Because you can have multiple business cases or different use cases inside your organization, and each one is going to be a little bit different. So, if it's one person using it, the cost isn't that big a deal. But maybe you're putting this on your public website as a chatbot, the cost is a big challenge because if you have 500 people asking questions a day, the bigger problem may be the performance. Like you want high performance on your public website, but it can't be too busy, right? But on the other side, say it's in your customer service organization so you're optimizing the way humans are interacting and you're trying to decrease response time for things. But in customer support, customer service, really accuracy is important because like if you're on a recorded call, you want to give the person the right information. So it's like, accuracy may be the most important thing to them. If it takes 2 seconds or 5 seconds or 10 seconds, they can talk around that, but it has to be super accurate. And then other things is like if you're using it in the back office, like if R&D is using it or parts of your organization are talking about your supply chain planning or your internal information, security may be the biggest concern. It doesn't matter how much the performance is. It's like you want to make sure it's highly secure. This shouldn't go to a public LLM through a public API. I want this to be, say, one that I've hosted internally or a partner's hosted for me. And I mean, that one obviously is the one that's in the news the most. So people are like, oh, we put our intellectual property on the internet. That's the one people think about the most. But in reality, the other two use cases are just as valid. So it's like looking at what's your cost, what's your accuracy, how performant is it, and security. And those things will skew and change based on your use case within different lines of business itself.
So with those examples, you're talking about these different use cases, one's, public cloud, one's private cloud, and the different performance. I mean, that would lead you to believe that you're not going to use one model to do all this, right? Because one that's highly accurate may cost more, like you said.
And maybe slow.
Or, it could, and really slow. But, website, you can't have visitors leave your website So that has to be a high performance. So I guess maybe accuracy could fall off for the sake of performance and cost, right? Because
Yep.
these things are going to get expensive, right? If you have a lot of
Yep.
traffic, they're going to get really expensive to even just operate. So
Yep.
if it does get too expensive, you have to be able to switch from one to the other, right? So you're not going to deploy one of these like you do your, let's say, CRM system or ERP system, where you pick one and stick with it because the conversion
Yep.
cost is so high. What's the conversion cost of switching LLMs?
So yeah, what you're talking about is huge, right? Because if you spent weeks and months of development to learn how to prompt one, we've talked about that in other podcasts. How do you prompt an LLM? Then you've written all the code behind it to connect to it. That's actually a huge change. That's actually a software development lifecycle. It's a project plan you have to do. So you want to be able to swap those very quickly because, like you mentioned, this isn't like an ERP. You're not just going to have one. You're going to have multiples, and they will change over time. It's like, what was really good today may not be as good in 6 months because there's a new, say, open source model that came out, or a new offering, say from Bart, Bear, ChatGPT, Watson. Someone has a new offering, which actually gives you more accuracy and more performance. So you want to swap those. And the other thing is, ideally, these will get cheaper over time. Like if you have, say, ChatGPT 3.5 versus 4, ideally the new one is always more expensive than the previous one. But it's that, is it good enough type thing? Like, so it is a weighting or a balancing act of like, is the accuracy good enough and the performance good enough for the cost? So you're not always going to go for the perfect one. It's like, you're not going to always take the, use the most expensive way to ship something. Like if you want to ship a letter and it has to be there tomorrow by 10, you're going to pay a lot for overnighting. But if it's something that get there in 3 or 4 days, you'll send it in a slower route. So it's the same type of thing. You have to look at each use case and balance which is going to give you the good enough answers, the good enough accuracy, the good enough performance, and they will change because as models increase, different ones come into the market, different ones are removed. They will change. And so you may actually say, today I'm using, say, ChatGPT 3.5, and Watson X comes out with a new one, or Bart comes out with one. You're like, okay, this accuracy is actually much better. I'm going to need to change because I need the accuracy of the new one, right? So they will change over time, but you don't want to hard code and have a software development lifecycle to swap them. You want it to be literally plug and play, swapping, say, interfaces for them.
Yeah, if we've learned anything in delivering software, it's that hard coding just freezes innovation, right? And these things, like they innovate so quickly, you're going to be frozen in time as somebody else outpaces you. And
the velocity in which you can change these and reevaluate them is key, right? Because it is early days and they're making huge advancements, right?
All right. So how do you choose an LLM? Like how quickly can you do this? How can you test them? Like I think we may be the experts in this, right?
Yeah, you may actually need to test them, right? So so if you think about the way we've done testing in the past, sometimes it's software testing, it's regression testing. So you ask a question, you have a standard response, so you regress over time to do the same. But in sports, we do tournaments, right? So if you think about a testing tournament, you will have 2 people pair off. They go to the next bracket, 2 people pair off, the next bracket. So it's literally, we want to create a tournament, if you will, to compare the LLMs to see how their responses are. And when you do that, you can look for accuracy. You could look at like response times. You could look at cost. All those things you can do through a tournament. So think about the same way you would bracket in a tournament. I think there's a good image right here about that, how it would look like a testing tournament, right? That's a great way to do it. People understand that.
Yeah. So we will definitely link to, so this is, all these images are from a paper that we've written, Comparing Large Language Models for Your Enterprise. So it's really a guide on how to do this. Like you can run your own tournament. So we ran our own tournament. against a third-party report, a report that we like because we always, we've used the several McKinsey reports in the Union podcast because one, they're very well done, they're very well researched, and the visuals are fantastic.
Yep.
So our tournament, Chris, we tested three, right? So we did ChatGPT 3.5, ChatGPT 4, and Watson X. What?
Yep.
How is the test set up? Like what? Can you explain to people like maybe what we did and how they could do that?
Yeah. So basically, we took this document, the McKinsey document, and this was actually, the State of AI in 2023, generative AI breakout year. And it was cool because it was actually where people are talking about what they've actually operationalized, what they've done. So we basically gave Krista this document. She read the contents of it. And then we asked her to say, when we give it a question, search this document for the answers and then give those answers to the LLM and ask them to summarize it. So what we did is we started to say with ChatGPT first. We said ChatGPT 3.5 versus 4. Given that they have the same answer, can you each summarize them to answer the question we've done? And then we use AI to judge that. So like normally judging in something like this is, you need to have some type of very consistent judging rules in that. So we ask an AI engine to compare them on accuracy, about readability, and that type of stuff. So we actually said, judge this to tell us which one's better. And so the trick is we use software to do that. So this happened in machine speed.
Right.
And then the winner. Yep.
Yeah, the winner. So you're talking about judging. How did we judge the winner? Like how does the AI know which one's better?
So what we did is we asked the AI engine, in this case Watson X, running Google Fawn UI 2 is the engine underneath it. We said, based on these facts, who did a better job of summarizing them? And it would actually give you a comparison. You can actually see, there's a slide there which says, there's the two answers, and it tells you why one was preferred over the other one, whether it was the number of facts that were given or the sentence structure, things like that. So we said, based on this is the information, who did a better job? And so we actually ask AI to judge AI's results. It would take forever for humans to do it, and it might be a little subjective. So it's going to do it in a more methodical, consistent way.
Yeah, to have a human read all the answers and judge it would, be incredibly inconsistent, right? Because one,
right.
we ran so many questions and we did the test so many times, like we ran it like 10 times, just to look at if there were any variability in the results. And you can see here, there's a little bit of variability of all the questions we asked. So all the visuals that we have are just one of the questions that we asked, like what is the most important objective using AI? So then we had everybody answer that, generate answers, and then judge it. It turns out, Watson was the best in this instance, but that was only one of 100 instances, right? So we had 10 questions that ran it 10 times. But it was interesting that the results were fairly consistent. Like Watson answered better, based on this test 42 times, ChatGPT 42 times, and then ChatGPT 3.5, that's a mouthful, 16 times. So, that's just one use case, right? We talked about other use cases earlier with customer service, agent assist. You would have to do this multiple times, and hard coding this would be a very timely exercise. And I don't think people have that kind of time.
Oh yeah, it would take an army of engineers, an army of data scientists, and months to do. And if we walk backwards to the use cases, like if you think about like FAQ answers and a public-facing chatbot, you're actually looking for like reading documents and summarizing things in paragraphs of data. If it's in customer service, you may dynamically give the model, here's the customer's invoices, this is their POs, this is the status of their shipments, and give it a lot of like tables of data, and then want it to infer things from the tables of data. So based on your use case, the type of questions and the source of information is going to be different. So you're going to want to test them to see which model does better on which type of answer. Is it because it's drawing a conclusion, or is it summarizing information in paragraphs, right? And we saw that when you were smart. When we looked at this, we're like, wow, it's kind of consistent. And then you turn the graph sideways, which quite honestly, I wrote this conversation in Krista very quickly. Probably took me 20 minutes. Scott ran it 10 times, so that took him an hour. And then it probably took him more time to build the charts in PowerPoint to summarize it. Right?
I guarantee you it took me longer to create the PowerPoint than to run the test, right?
So literally, we're talking 20 minutes of me authoring this in Krista, an hour of running it 10 times with 10 questions. And then that was the long poll was that. But what's interesting, if you look at the results by question bar chart, you'll see the third, fourth, and fifth. Watson X did a better job of answering those, but it was actually summarizing data inside of a table. So that tells you if your use case is to get tables of data and summarize them and draw conclusions, that LLM is better suited. Where other ones, where it was like summarizing, say, policies and paragraphs, data inside of paragraphs, ChatGPT-4 did a better job. It had better sentence structure in that. So you will, like we mentioned before, you'll want multiple of these. And it's partially when we talk about the accuracy, it's like because some models do better at answering different types of questions. Some will be more performant, have different costs. But this was really interesting because if you read the article and you look at the results, you'll figure out that some of these are very summarization based. Some of these were drawing conclusions based. Some things were stack ranking. Of course, Scott came up with the questions, and the point was to give us questions that had different types of summary information. So you guys could see that, hey, you can do this. This is literally hours of work. This is not an army of data scientists, engineers, and 6 months of that. We would say this is actually operationalized and production ready. Like if a customer said, okay, here's my document, here's a Word document, or here's 5 Word documents, and here's 2 Excel spreadsheets of my data, we could literally put this in Krista in a matter of 4 or 5 minutes, because the conversation just says, give me a zip file. And then they could come up with 10 questions to ask, and we could ask those questions of it and get the results, right? This is actually something, this is an hour's work. This is not months of data scientists and development.
Yeah. And I think that's where people are, right? Because
right.
Just the lack of understanding of what tools are available to, run a test like this. Because like Chris said, it was fairly simple. And we have, all of the data. So we'll link all of the data. We have this in a Google Doc that you can read, like all 100 responses and the reasons why each model won one test version over another. It's actually really, really interesting to read the reasons. I think the reasons are the most interesting part for me. But this is simple to do. If you do want to do a test like this, just contact us on the website and Krista.ai, right? And then we'll actually either show you how to perform the test or perform the test for you based on whatever document you want. Chris mentioned a couple of Word documents. This could be like your employee handbook or, something that's simple that you have on hand is going to be easy to do. And then it'll give you an idea of how easy and simple this really is. But so please
it would answer those 2 questions we started with, like, will this actually work for my stuff?
Yeah. Or
it'll work, which LLM will work the best, right? So it'll actually answer those 2 questions we started our conversation with.
Yeah, no, that'd be great. So Chris, just like to close it out, we talked about the different use cases. You're going to have to look at different, requirements for cost and accuracy and performance, and data security obviously is really important because people want to interrogate and ask questions of proprietary data. It's either in a document or a system, right? So we didn't really talk about systems. We're mostly talking about documents because we're trying to simplify this explanation. But just like if somebody is going to do this, what are the steps that they need to take? What are the 2, 3, 4 steps from this point forward? What do they need to do?
Yeah. So if you want to be very low risk, take something that is public available. Maybe it's FAQs on your website, it's recalls, it's information you may have on your website. we'll take the Word documents of that's source information, read it into Krista, and start answering questions. So that way you don't have to worry about proprietary information. Now, maybe, and that's great for that first use case. If you're in the second use case where we want to do this, we just need to start comparing them, and you've actually, say, hosted Hugging Face or an LLM inside your organization, if we have an API access to that, we can compare it to multiples, say something in Watson and yours and another one, and actually compare your homegrown or your home trained models to the other ones. And that one's just an exercise of, we would need access to it via the APIs, but that's something that can be done there. So I think everybody can probably find something to see, okay, how does this work, to actually get the concept of continuously testing this over time with stuff they have on their public website. You consume it and read it. And then the people are like kind of sold on it. It's like, oh, okay, I actually want to compare very specific models. That's just a little bit of work, and we can wire them up. And then, but that's not months, that's not weeks, that's a couple days of work to kind of wire those up to get the answers and then run these tests itself.
All right, that's fantastic. So thanks, Chris, and thanks for working with me on this project and helping me actually run my test for this report. So
Yep.
I really appreciate it.
Well,
One, please do read the report. Two, take a look at the data, and then three, contact us so we can help you run your own tests. So thanks, Chris, and until next time.
Bye.